So let's start again. Let's get rid of all this. Now, I asked you before to try and think about this question without trig expansions, okay? But you are now enlightened year 11s who know trig expansions. So what might you do with this thing? Okay, well the first thing, your knee-jerk reaction might be, well let's expand it, shall we? Okay, so sine A plus B is sine A cos B plus, okay, good. Okay, get used to it, alright? Now, you look at this and you think, okay, this is partly good, this is partly better, because I've got a sine A and a sine B here, both of which I know the values of, right? So I can sub them in, okay? But then, you realize you've made things better and worse at the same time, because you've got these cos terms hanging around, right? So what am I supposed to do with them? Well, you think about something like sine A equals 3 over 5. This is not just a mathematical equation that's sitting out there in a vacuum. It's describing a real angle somewhere, right? Now, sine A equals 3 over 5, I know A is acute, right? So that means I can stick A in a triangle. Okay? Now sine. Sine, which ratio is that? That's, which sides does it pair up? Opposite and hypotenuse, right? So sine A is 3 over 5, opposite over hypotenuse. Sine A is 3 over 5. Okay, that checks out, right? So whatever this angle, I don't know what the size is. Well, it should be roughly 37, whatever we worked out before. This is the ratio I've got, and this is a right angled triangle, right? That's what makes these trig ratios work. That's what you first looked at in year 9. So therefore, by that logic, the third side should be 4. So therefore, I do know what cos A is, right? Sine A actually implies what cos A is. So from this triangle, I can say cos A is 4 over 5. And you can use the same logic here, right? Okay, so 7 over 25, it's obviously a different triangle. There's B, okay? 7 is the opposite side and 25 is the hypotenuse, which makes the other side 24. And it's usually these questions come up with nice recognizable Pythagorean triads, okay? So, there you go, that tells you cos B is equal to 24 over 25, okay? Sine A, sine B, cos A, cos B, I've got all my pieces. Okay, so let's give it a go, shall we? Let's just substitute it in, this is the easy part, okay? Sine A is 3 over 5, cos B is 24 over 25, plus cos A is 4/5 times sine B, which is 7/25. So 3 by 24 is 72, thank you. 4 by 7 is 28. And of course they're all over the same denominator, which is 125. And that's 100 if I can add up my numbers, right? Oh, not you again.
Anyone of you mind? Brendan, do you have your document book?
Do I have it? Yeah.
No, you have one.
Yeah.
Okay. Thank you, sir.
You're on my class.
I'm just doing the head of sciences job at the moment.
Okay, sure. Thank you.
Hey, welcome back, everyone.
I'm holding my breath. Okay, that could have gone a lot worse, right? Okay. All right, so you can see it now. There is my 4/5.
Oh, I heard that.
Evan, we need to transition again.
Are you content? Did you see it worked, right? So it's not magic. It's not magic at all. It's the expansion. Okay? Okay, now, you remember I told you I would come back to this domain business later on, okay? Why did they have to say this? Like, if I got rid of this, most of this it looks like you can still work with, right? Well, okay, I'm going to illustrate why it's important by changing it a little bit, okay? So, where did I put it? Here we go. Let's make B. Let's take B, okay? And let's suppose that it's not acute, but obtuse. Okay, so what would I have to say about its domain? If it's obtuse, what's it between? 90 and 180, which is pi on 2 and pi, okay? Okay? And so this is, by the way, one of the reasons why you've got to watch out for this domain. As in many other questions, the domain will totally change your answer. Okay, let's give it a go. These things here, they break down. Why do they break down? It's not that, there's no problem with A, because I haven't changed it, okay? But there is a problem, a big problem with B. Yeah? Okay, so my trig ratios, they worked because I have 90 degrees here, right? I forgot to put it in here. But in any case, I can't make a right angle triangle. Yeah, I can't make a triangle with a 90-degree angle and an obtuse angle, right? Because you're like, here's my obtuse angle, and here's my right angle, and they do something to my triangle. Okay, so they don't work, right? So what am I going to do instead? Okay. Cos still has a value. It still has a value if it's obtuse, right? It's just that I can't fit it into this kind of triangle. Now, think with me. Think. Cos of B. Oh no, I have to think. Okay. What does cos look like? Cos as a graph. This is cos, right? I've got 2 pi over here. I've got pi here, and that makes this point over here pi on 2. Yes, contend.
Yeah.
Now between pi on 2 and pi, that's this part here I'm interested in, right? Cos of that angle is negative, right? Can you see? Because there's my angle, and there's cos of my angle, right? So it's negative, okay? Now that's why, by the way, it won't fit into a nice triangle, because the ratio is negative, it goes in a different direction, okay? Now here's the thing, we can use triangles, but you just need to draw the right kind, and you're actually, hopefully, familiar with these. You need to draw this old friend, right? Let me show you how it works, okay, and how it helps you solve this question. Okay. So I'm going to draw my A just the same, because A is between 0 and pi on 2. That's this quadrant here, 0 and pi on 2. Okay. So here's the way it works. There's A, okay. There's my right angle, which I do need, okay, and it's still 3, 4, 5. Okay. But B, because it's in the second quadrant, pi on 2 to pi, it's going to be over here. So I don't draw my triangle the same way I did before. I'm going to draw it off in this direction. Okay? Now, when you think about, okay, if B is over here, and sine B is 7 over 25. 7 over 25. That's opposite on hypotenuse. Okay? But now, when you're working out this third side, can you see this is the point of using this diagram, right? As I'm working out this side, it goes to the left of the origin. These values are negative, right? So this is not 24. I'm going to break a rule of measurement here. This is minus 24, isn't it? It's going in a different direction, okay? I mean, it makes sense. This 7 is a positive 7 because I'm going up. Does that make sense? Okay? And if I go down here, it'll be a negative value for sine, because that's why, see, sine is negative down here. Does that make sense?
That means the 25 is negative.
No, it doesn't, because distance from the origin here comes from the square root, okay, which is positive. Okay, so the 25 stays positive. Okay. All right, I'll keep going. So therefore, cos B is not 24 and 25, right? It's negative 24 and 25. Okay. So you can see this is what changes your answer to the question. Over here, the method is much the same, but my substitution will just be that little bit different. So this 24 here will be minus 24. So this 72 will be minus 72. So what's that? Negative 44, I think. And I don't think you can do much with that, right? That's it. Yeah. Now here's my point, right? See, now you understand why that's the case. Your calculator, when you do sine inverse of whatever, or cos inverse or whatever, right? It doesn't tell you the value that you want, it just tells you the first value, okay? And it has to, because it doesn't know which value you want. It could be any of these, right? Trig functions go on forever, right? So when you're like sine inverse of 3 on 5, it could be this one, or this one, or this one, or this one, and on and on and on. So the calculator can't tell you all of them, so it just tells you the first one. So, does that make sense? This is the method that we go through, okay? And if I change the question, and I said, well, don't tell me the sine expansion, tell me the cos expansion. You would just use a different expansion here, but it'll be the same numbers going into there. Okay, they'd just be substituted in a different order. Okay.